All right, everybody, welcome on in. We're going to get started here with our Math 1 beginning algebra class for the day. Still have some people showing up. Before we get started, couple things to mention. So remember the census date that I talked about at the beginning of the semester is coming up. Good news, I looked over the grades. Doesn't look like anybody needs to get dropped. Everyone's doing enough work that I can make the argument that they're participating in class. There's still one or two of you that are further behind than I would like to see. So if that seems like maybe that's you, you want to catch up. Okay, this kind of class, if you get behind, it can get very difficult to get yourself caught up. So I understand things happen. I have students with COVID and they can't work on stuff for a few days and stuff like that. It is what it is. But those kinds of things, whether it's COVID and beyond your control or whatever, it still can keep you from being successful in the class. So please do your best to not fall behind. Math classes are hard enough. If you're trying to gain ground because you got behind in one, it oftentimes is too much for people to succeed at. So please stay current. So just because you didn't get dropped from the course doesn't mean you can kind of take a deep breath now and sort of get lazy about it. Just keep doing what you're doing. From the effort that I see so far getting put forth, looks to me like people are on a good pace. We'll see how things go the rest of the semester, but keep this up and you probably can be successful in the course, right? So that's what we'd like to see. I would like to see a highly successful course. You obviously want to see that. The two schools involved in this class want to see people succeeding. So keep that up. And as soon as you start to feel like the class is getting away from you, or you're getting behind, or you're confused and it's starting to stress you out, get a hold of me immediately. Email me, contact me, whatever it is. Sometimes a conversation between me and a student can really change that student's perspective, and they feel like they can do it now instead of it feeling so overwhelming, like they just can't, there's no way they could get caught up. If you do it soon, when you start to feel like you're getting behind, then we can, hopefully I can help you with that and help you sort of figure out how to get yourself back on track. If you wait a couple of months, then there's not much I can do about it, right? If you're that far behind, not much can be done. So please contact me as soon as you start to feel like the class is getting to be too much, and we can talk about it in Zoom and hopefully make you feel a little bit better about the course. Okay? Let's see. So there's that. With that said, yeah, people seem like they're on pace for stuff. So I haven't received any emails. So, as always, if I don't hear from students, I assume, the old saying, no news is good news, right? So if I'm not hearing from students, I assume that means you're getting it. Looks like students are able to be at least somewhat successful with the homework. Students are largely completing the homework. You might be people might be one section behind or something like that. That's not like something to panic over, but you don't want to get too many sections behind. So I'll continue today with talking about proportions and ratios and fractions and that kind of stuff, and we'll continue moving forward dealing with those kinds of topics. And if you have questions, please put them in either chat, either the YouTube chat or the Zoom chat, as always, right? Because otherwise I'm just going to sort of plow ahead. So if there's questions, make sure you ask them, and we'll keep progressing with things, okay? Because I know this is one of those sections where sometimes people kind of skip since it's kind of related to fractions. Some of this stuff is fractions, but also percents are sometimes confusing for people, so it's tempting to skip over it, but it's a topic that you definitely want to master now, right? I mean, fractions, percents, that ratios, that kind of stuff, that's like real life stuff, right? And a lot of this math is real life stuff, but people just sort of make the choice to avoid it. This mathematics is stuff, you're all probably going to take out a loan sometime in your life, so you want to understand percents and rates and all that kind of stuff. So you can make good choices, smart choices for yourself, so you're not throwing money away. Okay? So let's get started then. So there's a few of these that, I think probably do a fine. Proportional reasoning. Let's take a look at that. Let me move this over. Guess it's good right there. Okay? So let's take a look. And remember, you can always watch those video. I know people start to ignore, excuse me. always happens. I start teaching, and all of a sudden I get the hiccups. People start to ignore this corner of information over here. Sometimes they'll look at the score maybe a little to see when they can get to the next type of problem. But make sure you're watching these videos. These videos, for the most part, are pretty good, right? They're not perfect. A student did send me one today where there was a misspeak in one of the videos where they had the right thing on the screen, but they said the wrong thing. There was a mistake in there. And then I did have in my Math 3 class, a couple students said specifically for a specific type of problem, they didn't think the video was very helpful. But by and large, I would say 99% of the time, watching these videos are going to help you complete what you're trying to do for the problem. So what I'll do is I'm just going to pick different types of these ratio problems today, percents problems, and we're going to work through them. And we're going to figure out how to do them, and then you'll be prepared to do them when you have to do them for your homework, right? So here's one. It cost Brody $9.80 to send 196 text messages. How many text messages did he send if he spent $4.20? Right? So you're just trying to figure out the rate. What is the cost per text message? Which I know seems kind of silly, right? But this was a thing like even like 10 years ago. Seems like at this point, even most of the older people I know basically are on unlimited text at this point, but everyone has different plans. So there might be, you might know someone who is still paying per text message, but most phone plans have moved away from this. But this was definitely a thing in the early days of, these fancier phones, that each text message was costing you 5 or 10 or 15, 20 cents, something like that. But even like my parents and stuff are now on plans where they, get unlimited texts and stuff. So we want to figure out, well, what is it costing me per text? Like how many texts am I paying per dollar? And to get this 420. Now, here's the thing about these problems. There is numerous ways to do these different problems, right? There's numerous different ways to do this. They all essentially come out to the same mathematics, but they're organized a little bit differently. But it's kind of good to see the different ways to do it, because sometimes the way that you'll see a problem done in the problem, you can memorize it and go, okay, I can reproduce that for my problem. But it doesn't mean you really can like use that concept in like critical thinking, right? Which is the point of this mathematics, is to use these kinds of things to do critical thinking in your everyday life. Because if all this is a memorization exercise, you'll forget it in 3-4 months from now. And certainly three months after the semester, you won't remember most of this stuff. But if you can think your way through a problem like this, then you can start to use it in your everyday life. And generally, the more mathematics that you can employ in your everyday life, the better choices you're going to make. You're not going to miss out on opportunities. You're not going to waste money. You're not going to do this different kind of stuff. So let's kind of just reason our way through this problem first, and then I'll show you. I'll show you I think it's how they have it set up in the video. Another way to set it up, but that way again doesn't really help you critically think your way through. So let's see. I'm going to write this stuff down. So $9.80. So we've got $9.80, and that's the dollar sign, for how many was it? 196 text messages. 196 texts. Right? No one really says text messages, do they? Just 196 texts. Okay, so what would we do in order to figure out, well, how much am I paying for each text message, right? And I can bring up I'll just do it on my phone calculator. So this kind of stuff, I don't mind too much if you use a calculator, right? You should know how to divide decimals. Like that's a pre-algebra skill, so you should know how to do it. But I don't expect, in real life, like look at me right now, right? I have a PhD in mathematics. If I'm going to figure out this text message rate, I'm doing it on a calculator, right? Why not? It's on my phone. Why not just calculate it? So let's see, where's my calculator? So if I've got 196 texts, and I have to think about this the right way. So what am I going to do? I'm going to do a division, but we want to do the division both the right way. Okay, so how do I know if I'm dividing 9.80 by 196 or if I'm dividing 196 by 9.80? And the answer is something that a lot of people don't want to hear. It's units, okay? This is why in chemistry class especially, but also in physics and some of the other sciences, they sort of complain to us as math teachers, and they say, you're all not teaching your students to use the units. We need students to use units in order to do the problems. And I say, I teach my students to use the units. I use units all the time to figure stuff out. There's a big push where students don't want to write units down. They think, I'll just remember what it is. And then they get confused and mess it up and do it backwards. So you're actually better off writing down the units, right? Go slow to go fast. It takes an extra couple seconds to write the units, but then you're not going to mess up the problem. So it's actually faster to do it that way. So what I would do for this is I would look at the units. I would consider, well, do I want dollars per text or do I want texts per dollar? I think it makes sense that we want to know how much we're paying for each text message. So that means I want dollars per text. So that means I want dollars on top, texts on the bottom, text messages on the bottom. So it's going to look like the following. So we've got $9.80, and this is, I'm going to write it out, dollars, just so it's clear to everybody. $980 over 196 texts, which is just short for text messages, right? So that means we're looking at dollars per text, just like maybe, you know, if we had miles over gallons, it would be miles per gallon. This is dollars per text. So if I use my calculator to simplify this, then if I go 9.80 divided by 196 equals 0.05, 0.05. Now what is that? That's we're forgetting our units, so let's just look back. Oh, it's dollars over text, so that's dollars per text. So 0.05 dollars per text. Okay, so what does that mean? That means every text costs me 5 cents. Every text costs me a nickel, right? It costs me 5 cents in order to send. Okay, well that makes sense. Okay, so now I know the rate. I know the price that I'm paying per text. Now we want to figure out, now we can answer our question, which is, how many text messages did he send if he spent $4.20? Well, basically what we're asking is how many 5-cent groupings are there in $4.20? So what are we going to do? We're going to divide $4.20 by 5 cents. So if we've got, let's do the same thing with our fraction. We've got $4.20. Oops. Over $0.05, right? We wouldn't put cents because it's not 0.05 cents. It's $0.05, which is 5 cents. So we got to watch those units. Notice when I do the simplification, the dollars cancel, which makes sense because our final unit should not be dollars. We're coming up with an amount. How many nickels are there in $4.20? That's not a dollar, that's an amount. So 4.20 divided by 0.05 is 84. 84. So 84 what? What is it we're talking about? Oh, we just did. We wanted to know how many text messages. Oh, 84. So he sent 84 text messages. So let's see. Answer, 84 texts. Submit answer. There we go. I got it right. Okay, so so the way we just did it is actually, it's the same way they did it. There's a couple, oh yeah, so here's the method 2. That's the one I was thinking of they were probably showing. I'll show you that in just a second. Okay, but what we just did was this method number 1, and that's the way that I think is more conceptual to understand, is you're thinking your way through it. And some people don't like that. Some people go, I just want to memorize it so I don't have to think my way through it, because thinking's hard. But the problem is then it's not going to really help you so much in the future, because in the future, when you have a new problem to solve, the way you're going to solve it is by thinking your way through it, not by trying to memorize some stuff that you remembered, in your college class for not very long. So this is giving us that rate. One text message, 5 cents, just like we found. We divided 420 by 5 cents to get 84 texts. Okay, so that's method number 1. Method number 2 is we set up a fraction where, notice how the units match. We have dollars over texts equals dollars over texts. Okay, that's important. That's what I'm about to set up with you and show you. This is another way of solving these problems. But like I say, students just kind of memorize this setup and they don't really know how to apply it to other problems. So that's why I like, it's fine to use this method I'm about to show you, but you should be able to do the one I just showed you, the one where you critically think your way through the problem. That's many times more valuable than the technique I'm about to show you. Okay, so we're going to set this up. Let's go to a new page and set this up. So this time we're going to have our $9.80 over, what was it, 196 texts. So that was the first information that we were given, was that, can we go back to the problem, $9.80 for 196 texts. So those should go in the same fraction because they're associated to each other. Now we're going to create another ratio with the units in the same place, but with the other information. So remember how it's dollars over text on the left and dollars over text on the right. You have to be consistent. So over here, our second fraction, we'll put in, these fractions are equal because they have the same ratio. So equals, and then I'm putting another fraction. Well, this one is $4.20 over how many texts? We don't know. That's the thing we wanted to figure out, was how many texts, right? So we just put an X. Let me scroll down here. Whoops, we don't need we're not using that. So I know you can say, didn't you just say to use units? Yeah, use units to set it up. You can write the dollars in here if you want. You don't have to. It depends how you want to do it. But like this would be that setup, right? So this is what they have in here. Now, they write 9.8 because 9.8 in dollars is the same as 9.80. I'm just writing it as 9.80 because I don't want people to go, well, why did they get rid of the last digit? They cut it off because it's a 0, so it doesn't really change the value of the problem. That's why we have 9.8 and 4.2, but I know that a lot of students get uncomfortable if their dollar amounts don't have 2 decimals in it. And the answer is going to come out the same way, whether we write it as 9.80 and 4.20 like I did, or you write it as 9.8 and 4.2 like the computer is showing you. They both work the same. Okay. They both work the same. Okay. So now we need to solve for x. Now we need to be a little bit careful here. This is one thing I don't like. In the directions, they tell you to use what's called cross multiplication. Many of you have used cross multiplication in the past. Many of you were taught that. Cross multiplication is not good. It's a trick that people are taught to skip actually thinking mathematically. And what it actually does is it backfires on students a lot. I see this in my classroom a lot, where students learn cross multiplication, and then what happens is anytime they see 2 fractions, they try to cross multiply because they don't really understand what cross multiplication is. They just go, oh, look, 2 fractions, let's cross multiply. And then like when we get to chapter 7, I think it's chapter 7 in this book, or in this, it's rational expressions that we get to. When they get to that, or just when they're dealing with fractions in general, they just try to cross multiply everything, and they end up doing so many problems wrong. Also, the cross multiplication only saves you like half a step. It's like literally half a step that you save, like 1 line maybe you save. So it's not like it really saves you that much, but it does confuse students quite a bit. So then what do? Well, in this case, what we want to do is look at this and say, well, I can't solve for x if it's in the denominator of a fraction. So what we need to do is get that x value out of the fraction, or sorry, out of the denominator of the fraction. And then we won't have fractions anymore. Doesn't that sound better? Oh, let's get rid of fractions in this problem because we already have decimals. I don't really want to deal with decimals and fractions. So what you're going to do is you're going to multiply both sides of this equation by the value that's going to get the denominators to cancel. And I'm going to do it in 2 steps. Once you get used to it, you can do it in 1 step. And you can do both of them in 1 step. But I'm going to do it in 2 steps just to make sure that I'm not doing too much at once and losing people along the way. So if I want this x to not be in the denominator anymore, I need to cancel it out. I'm going to multiply both sides by x. So this is where some of you have learned to cross multiply. This is actually the right time to cross multiply if you're going to do it. Cross multiplication is really just, it's a slight shortcut for what I'm showing you, which is the mathematical way of doing it. But again, it usually betrays people down the road when they start cross multiplying at the wrong times. So I'm going to multiply both sides by x, and that's going to give me 9. Oh, actually, I'm going to have to do it this way. It's going to give me, yeah, that's fine the way I had it written. So that's going to give me 9.80x over 196 equals 420. Right? Because when we multiply the right side, let's give it a little space there. When I multiply the right side of this equation, 420 divided by x, when I multiply by x, those x's cancel, right? So that's why we just get, not 420, 4.20. If I take $4.20 and I divide by x, and then I multiply by x, I just get 4.20 again, right? But over here, when I've multiplied by x, it's like multiplying by x over 1. So it becomes 9.80x over 196. Now what I'm going to do is multiply both sides by 196. So just like we multiplied by x to get this denominator to cancel, now I'm going to multiply by 196. So when I do that, when I divide, or when I multiply both sides by 196, I'm going to get 9.80x equals, but on the, oops. Actually, I don't need that anymore. We just need 9.80x equals, and then we've got over here 4.20 times 196 which then is 9.80x equals, and then we can use our calculator to, again, you should be able to do the decimals, but I don't expect you to do every single one of them by hand. 4.2 times 196 equals 823.2. 823.2. And now what do we have to do? Now we have to divide by whatever is multiplying our x, which is 9.8. So divided by 9.8 equals 84. Notice how that matches our answer before? So of course we should get the same answer either way we do it. Right, so we get our answer of 84. So you can do it either way. You probably should be familiar with both. Teachers are going to expect you to be able to set up ratios or proportions like we see right here. You're going to be expected to be able to do that. But also your teachers are going to expect that you can just reason your way through it by finding the price per text and then figuring out how many that should be, right? Okay, so a couple new things we just watched there. A couple new things we saw how to do. Let's go back. Okay, make sure if there's any questions, you're throwing them up here so I can, I'll stop if I see questions. Otherwise, I'm going to assume that everything's good. Okay, proportional reasoning. Now, here's an instance where we can actually do some of this You'd be surprised how much percentages you can do in your head, and people don't even realize it, right? Like a tip on a at a restaurant, people make it like that's really hard to calculate or at least approximate. It's actually not bad at all, right? So that's because if you think about it, if you want to find 1% of something, you just have to move the decimal 2 places, right? Because you're dividing by 100. What if you want to know 10% of something? Just move the decimal 1 place, right? For instance, let me show you how easy this is, right? People make this way harder than it needs to be. Let's say that you go to you go to a restaurant and your food bill is $20. And you say, well, it depends where you are and what kind of food it is, right? It's one thing if you're at a restaurant where they fully waited on you the whole time. It's another thing if you're at a place where you just make your order and pick up the food and leave, right? Usually the waiter that waits on you the whole time, probably tip them a little bit more than someone who just, they were behind a counter and handed you your food or whatever. So, it varies, and people have different preferences. 2 standards are that you would tip. It depends. Everyone's a little different, so I'm not trying to tell you proper tipping strategy. But a lot of times people will tip 15% or 20%. Those are 2 very common amounts. Well, figuring out 15% of 20 is really easy, and figuring out 20% of 20 is even easier, right? So how is that? Well, let's consider this. If your food bill is $20, then what's 10% of 20? So 10% of 20 is what? Right? 10% of 20, you just move that decimal 1 place, 2, right? 10% of 20 is 2, right? Okay, well, what's 5%? Right? If we want 15%, we need a 10 and a 5. So 5% of 20 is, well, if 10% is 2, what's 5%? 1, right? 5% is 1. So, and this was all stuff you can just do in your head, right? So 15% of 20, well, if 10% is 2 and 5% is 1, then 10% plus 5% is 15%. 15% of 20 is 3. You're just adding those 2 values together, right? So you spend about $20 on a meal. You want to leave 15%. Oops. And $3 you'd throw on there. And you go, you know what? This service was like really good. I want to leave them a 20% tip. Well, 20% of 20 is, well, if 10% of 20 is 2, then 20% of 20 would be 4, right? So then you leave a $4 tip. So if the amounts are at least roughly round numbers, it can be pretty easy to calculate this stuff. And actually, the truth is, if you do this with numbers like 20 and 30 and 50 and you get good at it, you'll find you'll get quite a bit better for doing it for, food shows up and your bill is $27. That seems like, oh, that's too hard to calculate. It's not bad, right? 10% of 27 is 2.7. 2 of those would be what? 5.4. 2.7 plus 2.7 is 5.4. There, $5.40 tip on that. So it's still something that you don't be afraid of trying to do percents in your head. I think some people give up and think percents are something only a calculator can do. You can do them, it doesn't take very much work to get comfortable with them and understand them at a better level. So you can do that. Okay, that same reasoning can help us here. 4,600 people attended a football game. So 4,600 people attended a football game. If 4% of the people who attended were teenagers, how many teenagers attended the game? I'm going to show you 2 different ways of doing this problem again, right? And they're both perfectly legitimate. So divide scale down to solve for the missing percent. Well, here's one way to do it. So what is our problem? We've got 4,600 people. What is this? 4,600 people attended a football game. 4% of the people who attended were teenagers. So 4% were teens. 4% were teens. Okay. Well, what is 1%? 1% of 4,600 is 1% of 4,600. Anybody know? That would be 46. How do I know? Well, we're dividing by 100, right? Percent means out of 100. So if we want to know what 1% is, you divide by 100. That just moves the decimal 2 places, making it 46. So 1% of 4,600 people is 46. So that means we just need to multiply 46 times 4 to get 4%, right? So 4% of 4,600 is, and this one's not too bad to do by hand, but I'll cheat. 46 times 4 equals 184. 184 people. See how you break it down into a percent that is simple, or a ratio that's simple to use, and then you can just apply it however you want. So 4%, 4,600 should be 184. Where's my box? Wait. Oh, they want me to put it here. I couldn't see the box there very well. So 184. There we go. We got it. Okay. They're doing it a slightly different way, but you can use that equation a couple of different ways. Okay, so let me show you another way. Here is a way using a formula that can be very helpful. So there's an equation that comes up that gets used basically whenever you're doing a percent of type problem. We've got amount equals base times, I'll write it as this way. So amount equals base times percent. So the base means the total number that you're talking about. The percent is whatever percentage you're talking about. And the amount is whatever one you're specifying in the problem. So for this one, we're talking about a whole group of 4,600 people. So that's our base, right? So I'm going to rewrite this now with the stuff in there. So amount equals. So for us, the base is 4,600 times, and the percent is 4%, right? Except remember that when we put percents into equations, we don't write it as 4%, we write it as the decimal representation. So 4% is written as 0.04 is how we write that. 0.04, that's how we represent 4%, right? 5% is 0.05, 50% is 0.50, right? That's how we write those. And then we would just use our calculator to do 4,600 times 0.04 equals, guess what we get? 184, which is the same answer we got a moment ago. So this way I just showed you is the way that you'll see a lot of videos will show you how to do the problem this way. It's perfectly legitimate. Just make sure you can kind of reason your way through the top way as well, right? For these, it's helpful to have the formula. It's helpful to be able to reason your way through without the formula. Okay, they both work, and we can see they both get you the same answer. So don't get too locked into just give me what I need to get the homework done. This is more about how do you learn this so that you actually can, all these problems in the future when you're taking statistics and you need to know percents and rates, and when you're in pre-calculus or college algebra or whatever class you end up in, you can still do these types of problems. Okay, but this amount equals base times percent will come up a lot. And it's a pretty easy formula, except sometimes people mix up the amount and the base. So if your problem's coming out wrong, it could be that you put the amount in the base, or you put the base in the amount. You switched them the wrong way. So you just don't want to do that. Okay? So that's a type of problem that we look at. And then they have ones that are just a little bit harder versions of that. Let's see. Should we do this one? Okay. At a football stadium, 20% of the fans in attendance were teenagers. If there were 390 teenagers at the football stadium, what was the total number of people at the stadium? Notice how this problem at first sounds like the problem that we just did a moment ago, but it isn't, is it? Right? The problem we just did a moment ago, they gave us the total number of fans, a percent, and then they asked us how many teenagers they were. Now they're asking the question, although it sounds the same, it's easy to go, that's the same problem. It's not. They are now giving us how many teenagers there are and a percent, and asking us how many total fans there were, right? How many total fans there were. So let's go back and use that same formula. So I've got, what, 20% and 390. Okay, so we've got 390 teens is 20% of the total group, whatever, we'll call it population. Okay, that's the problem we're doing. So let's remember we had this. Right? Amount equals base times percent. Now, percent is the easy one to identify because it literally says percent. So we know that the percent in question for our problem is 20%, and we write 20% as 0.20. So I'm going to plug that in. This will become 0.20. Now here's the question. Is 360 teens the base or the amount? Well, the base would represent the total. The total population of the stadium is what we're supposed to figure out. So 360 can't be the base. The base is the thing they're asking us. So 360 must be the amount. So then the amount is going to change to 360. So then what does this mean? I'm going to have to do a slightly different calculation to solve this equation because I was given different information. See how it's great? We're using the same formula we used a moment ago to solve this problem, but we're actually solving a different problem with it, right? There's three pieces of information in this formula: the amount, the base, and the percent. On any given problem, they can give you two pieces of information, and you're going to have to solve for the third. But it's not a very hard calculation. You're either going to multiply or you're going to divide, and then you're done, right? In this case, we're going to divide. So this becomes 360 divided by 0.20 equals the base. Well, what is that? So 360 divided by 0.2 equals 1,800. Right? You can do this division by hand, just like we learned in pre-algebra. Or like I say, I don't expect you to do every single one of these by hand. But if you've forgotten, if you look at that and go, I don't remember how to do that, you should, just look up a video real quick on YouTube or something. Remind yourself how to do it and go, oh, that's right. That's not too bad. Okay, so 1,800. So let's see if I'm right. Oh, they're making me fill in all the information here. Let's see. So this would be 20% of 390. And the total here is, what did we say, 1,800? 1,800. Uh-oh, what did I do? Did I enter it wrong, or did I actually do it wrong? Oh, I think I did do it wrong. I think I did my calculation wrong. So, oh, because okay. So here's where I messed up. See how I messed up? The problem is 390. Over here I put 360. So that's where my mistake was. So this I just need to change to 390. 390, which will actually make it looks like 1950. See, easy mistake to make. My mathematics all there was right, but I had the wrong number from the problem. I see students do this all the time, right? So that's why the first thing I checked wait, do I have my numbers right? And then it turns out I don't. I would say half the time that a student asks me a question in class, it's because from transferring the information from the homework problem that they're looking at to their actual like work where they're calculating things, the information became something else like I just did. That's probably half the time that I see a student be stuck. So let's try this again. 1,950. Hopefully I got it right that time. There we go. Nailed it. Okay. So there we go. So that's how you do that type of problem. All right. What do we got? A little bit more time. I can cover a little bit more here. Let's see. So that's good for proportional reasoning. Constant of proportionality from context. Which one was this? Oh, for this one, which one shows a proportional relationship from X and Y? That means these things should be going up in a proportional manner. So like this one's not. This one's actually going up in an exponential manner. Oh, no, it's not. Let's see. That one looks like it's going up in a proportional manner because it's all multiplied by 2, right? You double 2 to get 4, double 8 to get 16, double 14 to get 28. So that's proportional. Basically, it means whatever number you're multiplying over here to get this one, it should be the same for all of these. Here it looks like this is going up proportionally. I think that one is. This one looks like it is not going up proportionally. And this one looks like it is probably not. Let's see. I'm doing this in my head because I want to get to another problem actually. Oh, wait a minute. So it's asking which table shows a proportional relationship between X and Y. So it's A because it's 2's all the way down, right? When you just double across. So you take your X value, multiply by 2, you get the ones and the Y's, right? So you can take any Y value, divide it by the X value, you get 2. So that's how that one's done. All these problems down here where it's like percent of whole, percent increase, decrease, stuff like that, that you're going to be using that amount equals percent times base formula. So just keep using that and they should all fit together. Let's see. Let's do simple proportions. So here's like what I was showing you a few minutes ago. So this one, you would multiply both sides of the equation by 2x, and this should end up being 4, right? So we kind of covered how to do that problem already. Let's see, what do I want to do with 5 minutes left? Let's find percent increase or decreasing. So 1 year the population of a city was 160,000. Several years later it was 140,800. Find the percent decrease. So you want to be careful with the we may not even have time to go through it, but we want to be careful with the language for increase and decrease. Sometimes people get confused by that. For instance, here's an example. Let me show you this one. Let's say that there is a coat, or let's say a pair of shoes. You want to go buy a pair of shoes. It's normally $100. For the weekend, the shoe store has reduced the price of that shoes by 10%. Okay? But you didn't get a chance to get over there and buy them, so the shoes are still there. The price was reduced 10%, but now the sale's over, and they increase the price of the shoes by 10%. So normally people would go, well, isn't it back to the original price? And the answer is no, because you have to pay attention to when the price is being increased or decreased. The first increase of 10% was applied to $100, right? The original $100 price of the shoes. Whereas when we increased the price, that was based on the sale price, which was lower. So 10% of 100 is different than 10% of 90. So when you decrease it 10% and then raise it 10%, you don't end up back at 100. So that's kind of the big thing you want to be paying attention to. when we do that. So they'll, there's an example in here. So you're basically looking at you're basically looking at your percent, that same percent equation that we were using before, because you'd have what? You have the original price of the phone, and then the increased price of the phone. And notice how you get 1.03 here? That throws people off here. What is that? That's 103%. But the original cost of the shoes, or whatever, in this case it's the phone, was 100%. So that's a 3% increase. It cost 103%. It's at 103% from 100%. So you're looking at a 3% increase. Okay, you can also do tax and stuff this way if you want to calculate it that way. Okay, so we might talk about a little bit of this more, right? I know it's kind of a big topic for people. Most of it you saw in your pre-algebra class, but I know people get a little bit rusty with it. So I will see you next week. This class is a Tuesday, Thursday class, so it is not affected by the holiday next week. But for those of you who may have Monday classes, just pay attention to the fact that there's a holiday next week. And we'll go from there. Send me questions if you have them. If you have questions or concerns about the class, if you have a homework problem that you're stuck on or you don't understand how to do it, send me a screenshot of that problem, and we can look at it and talk about it. Otherwise, I'll just sort of make up what I think I want to talk about next time in class, and we'll go from there. Okay, so you are welcome to stick around in the Zoom meeting and ask me questions. I'm going to shut down